All right. Thank you all for joining today. My name is Nick Klein, and I'm a project leader with Delivery Associates, and I am assisting the Clean Energy Buyers Institute, or SEBI, with today's webinar. This year, SEBI has hosted a series of Market 101 webinars, often affectionately called Sebinars. You may have joined their RTO Governance 101, Transmission 101, or Resource Adequacy 101. Today, we're taking a break from the 101s and instead inviting an expert to share some new thought leadership on market design options. Today, I'm joined by Jack Wadley, Senior Associate at SEBI, Heidi Ratz, Senior Manager at SEBI, and Kelly Joseph, who is the Senior Fellow of Electricity Market Design and Clean Energy Transition at the World Resources Institute. Before we get started, we have a few housekeeping items to attend to. Please feel free to send me your questions as a direct message as you have them, or during the Q&A at the end. I'm here today to help moderate our chat, lead Q&A, and share links to useful resources. I'm also on call to help if you need any tech assistance. Finally, a recording of this webinar will be made available on the SEBI website. Now I'd like to invite Jack to share a little bit more about this seminar and what it will cover.
Thanks, Nick. Thank you all for being here with us today. We're really excited about the presentation. Before we dig in, just going to lay out a little bit about what we're going to cover and how we're going to do so. First, I'm going to give a little bit of a background on who SEBI and SEBA are. Then I'm going to pass it over to Heidi, who's going to provide some information on SEBI's recent work and 2023 seminar plans. Then we're going to have our fantastic guest speaker, Kelly, come up and present some emerging research on market options for resource adequacy coordination that I'm very, very excited to hear about. Finally, we're going to reserve a little bit of time at the end for some Q&A. So as you have questions, please feel free to drop them a message to Nick and we will facilitate the discussion at the end. Thank you, Nick. The Clean Energy Buyers Institute is a public benefit institute dedicated to solving the toughest market and policy barriers to achieving a carbon-free energy system. Our affiliate organization that you may have heard of is the Clean Energy Buyers Association, or SEBA, which is a business association who activates a community of energy customers and partners to deploy market and policy solutions for a carbon-free energy system. Collectively, the two organizations, referred to as the Alliance, have a shared 2030 aspiration of a 90% carbon-free U.S. electricity system and a global community of energy customers. We may mention some of SEBA's work in this webinar to showcase how customers are engaging on critical wholesale market topics. With that, I'll pass it back to Heidi to talk a little bit more about SEBI's work.
Thanks, Jack. So before we dive in, we mentioned that SEBI is focused on solving some tough market and policy barriers. And I just want to take a moment to highlight the work that SEBI does, because we have several programs. We have our Beyond the Megawatt program, which looks at the impacts of energy projects, noting that sometimes they have different impacts that are environmental or societal. We also have our Decarbonizing the Industrial Supply Chain Energy, so the DISC-E program, which is about accelerating the market for low carbon industrial commodities. We also have our Next Gen Procurement Initiative, which maximizes the decarbonization impact of different procurement decisions. And we have our Small and Medium Business Accelerator called SAMBA, which is really about helping customers of all types and sizes make some progress with their procurement goals. But this webinar specifically, or seminar, is part of our 21st Century Electricity System portfolio. So for a little bit of history, back in 2001, when we were still REBA, we commissioned this report, Designing the 21st Electricity System. And it was really focused on some key questions. So what does the low carbon grid of the future look like? And how is it going to operate? And then to get there, what policies do we need? And then thinking about everything we need for the future, what is the role of the large energy customer? What are the things that makes the most sense for large energy customers to be engaging on? And then from this report, we've been able to start building out white papers. For example, we'll drop into the chat. This year, we released a white paper that was around priorities for customers and transmission, how you make sure transmission planning is looking at customer goals and projects. But outside of white papers, we also have primers, just basic 101 on different topics, and seminars, obviously, like the one you're listening to today. So Jack, or next slide. I just want to note that from this report, that prioritization, where is the large energy customer voice needed? We came up with these priority areas. So one is expanding organized wholesale markets. Another is digging into market design reform. I know there's a lot of elements of that, but also market monitoring and performance standards, governance of RTOs and ISOs, transmission expansion. That's why we released our paper this year. Looking at the changing nature of utility regulation and resource procurement, and then just generally innovation in clean technology and the impacts there. So I just want to take a moment to note that as we begin to build out this portfolio even further and bring in external experts and talk about innovative ideas, but also continue providing this education, we would love to hear from you. What are you interested in? Even now, you could throw it in the chat, or just generally, if you're watching this recording later, feel free to reach out to us. We would love to hear on these topics what you'd like to dig into more. What are the big questions we should be looking at? Who are some good speakers you'd like to hear from, just to make sure we're meeting the needs of everyone. So with that, I'll stop and hand it back to Nick, I think.
Thank you, Heidi. All right, let's turn now to Kelly and learn more about her research. Kelly is a senior fellow with the World Resources Institute. WRI is a think tank that works with large energy buyers, utilities, policymakers, development institutions, and urban leaders worldwide to accelerate the transition to clean, affordable energy. Kelly, take it away.
Thank you, and thanks for the invitation to be here and share some of the work that we're doing at WRI around some of these big picture policy questions, market design questions, as we're thinking about the grid transition. And what I'm going to talk to you today about is some work that's going to be coming out next year, looking at some market options for resource adequacy coordination. And I'll talk about all of those concepts in more detail in the presentation. You can go to the next slide, but just to let everyone know, this is still in draft form. And a lot of what I'll be talking about, there's going to be a lot more details in the paper. So there'll be very specific details on, for example, some of the new imbalance market designs that are coming out in the West, EDAM, Markets Plus, a deeper dive into exactly some of the market designs within RTOs, and then some of the discussions that are happening as the transition is taking place. And then even more detail on what I'll talk about today, but some of these proposed ideas for organized long-term markets for resource adequacy. And the unique contribution, I think, to what's happening at WRI and the work here is that a lot of the focus on resource adequacy tends to be around metrics. So how do we actually think about coordinating and planning the system from a perspective of having a lot of new types of resources on the system, whether that's renewables and inverter-based resources, or whether we have to think about how we plan for load and how load might be changing, and more around some of the metrics of how you would do that. And what we're looking at here is, in addition to those metrics challenges associated with resource adequacy, what are some of the market designs that are in place today, and how might those also need to be looked at in more detail as we're moving through this transition. So you can go to the next slide. So to start with, what exactly is the resource adequacy challenge? We talk about this concept. What does it actually mean? I like to think about resource adequacy as what we need to do to procure the right mix of resources for grid operators to keep the lights on. And that procurement takes place in the long term in order to enable short-term market operations. So it's a focus now, again, because of this transition from a mostly fossil-based system to one made up of more renewables. And there's growing realization that we do have to have new thinking, not only around the metrics, but perhaps also around the procurement mechanisms and the market design around which we do that as well. So you can go to the next slide. So in order to put that in place, when I say long-term procurement of resources for what grid operators need in the short term, what exactly are grid operators doing in the short term? And I've tried to boil this down to two, as simple as I can make it, two of the big things that grid operators are doing, and they're doing a lot. But the two big things that they're doing are ensuring that they're constantly balancing supply and demand so that there's enough generation to meet demand, not too much generation, not too little. And even more important, they're ensuring that they're meeting mandatory reliability standards. So those mandatory reliability standards, mandatory reliability requirements include things like procuring sufficient contingency reserves, ensuring that they have black start capacity, managing voltage, managing transmission stability limits, everything that they're doing to balance supply and demand within required reliability standards. I put this image on here about the frequency because that's a big part of what they're doing. So a big part of what grid operators do within an entire Eastern interconnect is make sure that the frequency is within a defined range. And that's important because generators, if you have too much generation or too little generation, or vice versa, too much demand or too little demand with more generation than you need, you can change the frequency. And generators, especially traditional generators, are only designed to actually work within a defined frequency range. And a lot of them have actual mechanisms to automatically disconnect from the system if the frequency is outside of a particular range. And that matters because as grid operators are constantly balancing supply and demand within all of these reliability requirements, it's very difficult to control the flow of electrons. Electrons flow according to the path of least resistance, and they flow instantaneously. So that means that if you lose a generation resource or if you lose a transmission line, the flow of electrons changes instantaneously. And what grid operators are required to do is manage the system to withstand the loss of any key generation facility or any transmission facility. But if simultaneously everything starts to disconnect because the frequency is out of range, or power starts to flow in a different direction than what was planned, they have to be able to react to that very quickly. And if that starts to happen in too quick of a fashion and things start to get to the point where you actually have electrons flowing outside of what grid operators can balance and meet within reliability standards, you end up with the possibility of having potentially cascading outages that could lead to a blackout. So all of that to say, what they're doing second to second, minute to minute, hour to hour is balancing to meet mandatory reliability standards in order to keep frequency within a particular range, and the bigger picture to do all of that to avoid cascading outages. It's important to at least have that discussion, think about that in terms of when we're talking about market design, when we're talking about where the grid of the future can look like, we also have to keep in mind what grid operators need. So you can go to the next slide. So what are some of the challenges that not only the grid in general, but grid operators are seeing as they start to think about as the grid is transitioning from a mostly fossil-based system to one with more renewables, potentially more interactive demand? What are some of the challenges? It's not easy to match supply and demand. It's not easy what grid operators are doing every day, but it's easier when load is very predictable and generation output is very predictable. So when you have, a clearly defined amount of demand that's going to be on the system, it's pretty well known. You don't have consumers that are either interacting with their energy supply or having, rooftop solar behind the meter, distributed assets. It's you have a known demand or a known load. And when you have generation assets that are relatively similar, there's some key characteristics that might be different, but for the most part, they're relatively easily substitutable. So if one goes out, you have others just like it that can easily come back on to replace it. Under that kind of a framework, that's our traditional peak planning. That's what we do today. That's what's been happening for many, many decades. And all of that is starting to change. So when load starts to become less predictable, when you have, again, consumers actually interacting in some way, a lot of behind the meter assets that are taking some of the load off the system, and when you have generation output that is more variable, then the traditional peak is not necessarily the piece that everybody's planning to. We're starting to think about planning to what's called net load. So when I put this graph down at the bottom. So a couple of years ago, with the heat wave in the West, California ISO actually had to put in place some rotating outages. And what you can see, the blue line is traditional demand. So that doesn't go away. That's always there. There is demand on the system. But the orange line shows what's called net demand. So that's the load, the demand that's on the system after accounting for, behind the meter resources and individual generation. And most of that is, renewable, most of that is solar. But the gray line shows at the moment when the grid operator actually had to put these emergency alerts into place. And what you can see is that it clearly occurred after the traditional peak demand. So the system is planned for the blue line, but the challenge came where the orange line peaked, when net demand peaked early in the evening as solar started to come off the system. But yet again, that demand is still there. Everybody's still looking to use electricity. So that's the changing concept. And that's a different planning framework from which we operate today. The additional piece I put on here is this idea of intra-hour uncertainty. And that has to do with how grid operators plan for the system in day-ahead markets and real-time markets. So in the day-ahead market, they are committing assets over an hourly period. And what we've always had are top of the hour challenges as, what happens in real time, ramping concerns, anything that typically happens at the top of the hour as that day ahead market is catching up with what's happening in the real time. But we're starting to see, more of that intra-hour uncertainty versus just this hourly uncertainty. So all of this combined is challenging grid operators, is challenging market design. And these are some of the changing aspects of resource adequacy that we also want to keep in mind. So you can go to the next slide. So when I say short-term markets, what I'm thinking about are day-to-day grid operations. So day-to-day short-term market operations, short-term grid operations, what exactly, who is managing that? How does that work? What are we talking about when we talk about those kinds of market structures? So the two biggest the market structures that we have in the US are either balancing authorities or balancing areas or RTOs. So in the West, for example, you can see there are almost 40 different types of balancing authorities or balancing areas. And each of these individual balancing authorities are doing what I explained. So they are matching supply and demand. They are ensuring that they have contingency reserves. They're managing voltage, transmission stability limits. They're doing that all individually. And within the West, you have nearly 40 entities, of which the California ISO is one. And then throughout the US, we have RTOs. So RTOs are a type of balancing authority where they're doing this on a large footprint, and the RTO is the entity that's doing all of it. So you can go to the next slide. So when we're talking about some of these newer market concepts that are happening, particularly in the West around imbalance markets, what exactly are they doing? How are they different from an RTO? And what is the additional feature that these markets are providing? So in an RTO, similar to an imbalance market, both of these are voluntary constructs. Anyone can decide to join an RTO, to become part of an imbalance market. There's no requirements for either of these types of market structures. But there are some differences should entities decide to take part in one of these. The biggest difference between an RTO and an imbalance market, there's two pretty big ones, I think. The first is around how they manage transmission access. So in an RTO, access to transmission is managed by price. So as long as there's sufficient transmission, depending on how your asset gets dispatched, the management of transmission and the management of what happens on the transmission lines is managed through price, and particularly through a congestion price. In an imbalance market and in balancing authorities in general, transmission access is managed through a contract path. So you can have access to transmission, but it must be predetermined. You must have a contract associated with your use of that transmission in the first place. The second big difference is what they are actually procuring and what they are actually balancing. So an RTO across the footprint is sharing all energy and ancillary services. So all of these mandatory reliability requirements are shared throughout the footprint, and the RTO is responsible for managing that. In an imbalance market, they're sharing imbalance reserves only. They're not sharing ancillary services. So each of these individual balancing authorities at the end of the day are still responsible for managing their own reliability requirements individually. They're all procuring their own contingency reserves, managing their own voltage requirements, transmission stability. They are the entities that are managing access to transmission and managing sort of the day-to-day reliability requirements that come within their own footprint, versus an RTO, again, where the RTO is the entity that's ultimately responsible. You can go to the next slide. So now we've talked a little bit about day-to-day grid operations, what it is that grid operators are doing, and kind of big picture how these different market structures are set up. So now let's dig into some of these longer-term procurement mechanisms to manage these short-term market operations. So again, resource adequacy, again, is about these long-term procurement of the resources needed to maintain reliable short-term grid operations. And in the US, we really have three main constructs for this. So the first is through some kind of IRP or integrated resource plan, or some kind of either state-directed or entity-directed procurement. So there's a clear plan of what's needed and a clear plan of what resources are going to be meeting that plan. In energy-only markets or centralized capacity markets, these are areas of the country where there were previous decisions to move to restructuring. So entities that required the divestment of generation, the introduction of retail choice markets, that's where you see energy-only markets or you see centralized capacity markets. These are the three mechanisms by which we ensure that we have the right mix of resources available to grid operators in the short term. These are the market mechanisms under which that happens. You can go to the next slide. There are some challenges associated with resource adequacy market designs as they exist today when you have a high renewable grid. And any of those concepts, and all three of those concepts, the first applies. So managing, bringing on clean resources, bringing on low-cost resources, bringing on renewable resources, and ensuring that you have sufficient resources to meet all mandatory reliability requirements, ensure that grid operators have access to balancing resources to provide balancing services, and have all of these newer resources coming on. That's a challenge under any market construct. Under the market constructs that rely on an LMP or on a spot price alone as the investment signal for new or existing generation, so energy-only markets or markets that have a capacity market design, it's becoming more challenging. Those markets are relying on the spot market price signal as the key signal for ensuring that they have new generation and or keep on existing generation. And there's some concern going forward that there could be additional price volatility. And that could start to happen because there will be more instances of $0 or negative pricing when assets with RECs or a PTC or a ZEC or any other kind of incentive outside of the market construct, where these assets are on the margin, you'll tend to see $0 or negative pricing. When those assets are not on the margin, you'll tend to see a much higher price. So there's the potential that you could have higher price volatility. In addition to, and the paper will talk about this in more detail, but in addition to some of the ongoing price formation challenges that are already in markets with an LMP and markets that rely on energy and ancillary services pricing as the investment signal, exacerbating some of those challenges as you start to see some of these additional resources coming on. So that's part of the impetus for thinking about what are some other market designs that we could be thinking about other than energy only and or capacity market. So you can go to the next slide. So I want to talk about WRAP. So WRAP is the Western Resource Adequacy Program. And it's important to note that it's not quite fitting into any of those buckets. So it's not a coordinated procurement program. So it's not an IRP program. It's not a capacity market. It's not an energy only market. The intent of WRAP is to enable these imbalance markets where you can actually share imbalance reserves. And what it's doing is kind of going back to the beginning where we talked about this difference between reliability metrics and resource adequacy markets. So it is setting up a shared mechanism for having a shared reliability metric. And what do I mean by that? There's a number of ways to measure under traditional system planning how much generation resources and of what type you should have on the system for grid operators to be able to keep the lights on. The traditional standard is this 1 in 10 LOLE event. And so what WRAP is doing is creating a common framework and a common reliability metric across all balancing areas to think about system planning in order to, again, enable these the sharing of these resources in short-term market operations. It's also putting in place a common framework for capacity accreditation. So when you think about what types of resources you are bringing onto the system, it's creating a way for all the different balancing authorities to have a common mechanism for evaluating the capacity on their system. So whether that's an unforced capacity metric or some kind of ELCC, it's creating a framework for everybody to have the same metrics, but it is not a coordinated procurement mechanism. And it is not setting up a market in which you procure these. That is still done outside of this framework. It's just setting in place the rules, if you will, around understanding the generation assets that you have on the system and how that fits within the broader footprint. So you can go to the next slide. So coming back to kind of the discussion that we were having at the beginning and setting out, what it is that some of the challenges are with resource adequacy and how we might think about market designs and market coordination that might enable us to procure both the kinds of the clean resources, low cost resources, renewable resources, and resources that satisfy reliability requirements and enable grid operators to ensure that they can still meet these mandatory requirements. There are concepts emerging for what are called organized long-term markets. And what these are hybrid markets. So the idea would be you would have competition for the market. So competition for this day-to-day market operations, day-to-day, how resources are dispatched, meet supply and demand, but you're not relying on competition in the market alone to provide investment signals, meaning as generation resources are dispatched and as generation resources are used day to day, and that creates a particular price, you're not relying on that price in that market alone to provide investment signals. The investment signal is coming from someplace outside as you're competing among other types of resources to provide day-to-day short-term resources and short-term grid operations. And these markets can be either purely financial markets, or they could actually be physical markets. And I'll talk a little bit more detail on the next slide about some of these concepts that are out there. You can go to the next slide. So I'm not going to go into extreme detail on each of these here, but I'm going to let you know that these are all the different types of organized long-term markets that are under discussion today in some format. And all of these markets are different in some ways and similar in others. I would say that the similar aspect to all these markets is the recognition that the system is changing and that new resources are coming on, but we need to both meet grid reliability requirements and bring on these new resources. Whether some of these market proposals do both, i.e. they enable both the physical requirements of assets that are needed, or they only do one, which is they are a purely financial market and they're not necessarily coordinating both the procurement of clean resources and reliability resources. That's also a major difference. So some of the proposals out there are looking at, for example, standardizing in some way the virtual PPA that is individually negotiated today. So coming up with an auction structure and a mechanism for standardizing that. Another somewhat similar, but in this one would be looking at diversified portfolios. So entities can procure whatever they want in a portfolio. It could be seasonal, it could be time-based, location-based, it could be, excuse me, any type of portfolio that anybody wants to put together on their own. They would be procuring that, and those would be used in short-term market operations. Another is looking at kind of taking a step back and saying we have RECs and we have ZECs and we have, clean energy credits, but creating some kind of clean energy market where you would procure all of those. This market kind of mirrors the existing capacity market structure in that the idea is energy and ancillary services prices are not on their own or insufficient. We need some kind of capacity market to enable missing money. And this is the idea here. So this would be the missing money for clean resources are, a ZEC or a REC or whatever. And this would be some kind of a standardized auction or standardized market in which you can go and procure what you need in order to, ensure incentivize your resource to come on. Another proposal under discussion in the Northeast, in particular, where we have capacity markets, is this idea of a forward clean energy market. So Brattle's put forth a proposal that would separate out the procurement of clean energy resources. It would be another capacity market auction similar to this bilateral clean energy market concept, only that it would be completely state-run, state-determined. They would determine what kinds of resources are needed to be procured. And then you would have this separate capacity market to procure reliability resources. On the right, these are designs that are attempting to kind of put everything together. So not just have a financial market, but also have some physical requirement that goes along with that market. So one would be to have each individual LSC would have a requirement, or utilities would have a requirement to procure a certain amount of resources for every hour of their need under some forward duration. Another would be to what's called an integrated RA market. So that would be looking at similar to what California does today. So you have, some kind of system-wide need that everybody has to meet, and then you have location-based needs, and then you have some other capacity product resource adequacy product that is needed. So whether that's some kind of ramping or some kind of flexibility, but it would be somebody would determine, most likely the grid operator, potentially the RTO would determine exactly what's needed, and then entities would go out and procure that. In the precise renewable input system expansion model, or PRISM, the idea here is to actually use policy targets in coordination with reliability targets, and actually think about, a lot of these models that are out there that say it's 100% possible to get to a 100% renewable system. Here's how you would plan the system. Here's the kinds of resources you need. Here's how much transmission you need. It would be actually to take those models and say, this is what we know we need to do. Here's the policy input. Here's the reliability requirements. Let's competitively procure exactly those resources. It's much more detailed than that, and there are mechanisms under which you ensure that you're not, keeping resources on that you might not need, and mechanisms for retirement. This model also enables some transmission planning, because it would actually look at different types of resource procurement under different types of policy options, whether you build out transmission or rely on distributed resources, or build more storage, or whatever it is. And then finally, another topic under discussion is what's called a reliability backstop. So this would be grid operators know they need certain resources in certain locations, And they would be procuring very specific resources for those very limited times when the system is under stress, and they know what they need, and they're just procuring those resources and some kind of reliability backstop. So all of these are discussions that are out there today to think about how do we make sure that we have clean resources on the system as we're managing the transition, that we also ensure that we have resources that grid operators need to meet mandatory reliability requirements to keep the lights on. How do we mirror those two goals? How do we do that? What kinds of auction structures might we be thinking about? And for those of you who are wondering, which markets are today thinking about any of these concepts, there aren't any, except for the forward clean energy market being discussed in markets with capacity markets. Other than that, these are in the early stages of thinking about what these auction structures might look like, what might be useful, but we don't have anywhere where we're actually wrestling with these concepts and starting to think about how could we put this into an existing market design. So I'm going to stop there. You can go to the next slide. That's just the concluding slide, but happy to answer any questions and look forward to the discussion.
Thank you, Kelly. All right, so we are moving to the Q&A section. For members of the audience, if you have questions, please share them directly with me in the chat. In the meantime, Jack is going to share some questions.
Thank you, Nick, and thank you, Kelly, for that phenomenal presentation. You have got me all sorts of excited about all the different ways that we can improve markets. I have a couple of questions. The first is a clarifying question we got from the audience. Can you provide us a definition for ancillary services, please?
Oh, yes, I should have probably done that early on. So ancillary services, they have been called ancillary because they were something that just came along with the kinds of resources that were on the system before, but they're actually very essential. So they're kind of undergoing a PR change, if you will, to be called essential reliability services. So these are resources that or services that grid operators need to keep the lights on. So these are things like we procure a certain amount of generation every day, but we also keep resources in reserves because some of those generation resources might not be available. So we turn to our contingency reserves. These are also things like what kinds of black start capability do we need to procure? If the system were to go down, how do we bring it back up? These are resources that provide voltage stability. So there are, and these are all the pieces that go into the mandatory reliability requirements that grid operators have to meet. So they have a certain amount of contingency reserves and a certain type of contingency reserve in particular locations. Those are all reliability requirements that grid operators manage to.
That's fantastic. Thank you so much, Kelly. So a question I have for you that's a little bit more in depth. Can you talk a little bit more about how resources needed to meet goals like reliability, least cost, or clean are determined? And how would states with differing goals manage some of those differences?
Yeah, so that's the challenge. So right now, individual states have individual RPS goals. Right now, we have a huge federal policy around tax incentives for particular types of resources, but we don't really have a coordinated mechanism for any of that outside of what individual states are doing and these tax incentives. We have RGGI programs, we have attempts to think about pricing emissions. We don't have a national clean energy standard, which would have a national target for particular kinds of resources. So we have individual states with goals and targets, and then you have individual voluntary buyers with their own individual targets and requirements, if you will. But we don't necessarily have a coordinated mechanism for handling that. So certainly the designs that would say, let's take policy requirements into account, thinking about how you do that, who does that, and how you coordinate that is part of the challenge. I lost you here. I think you might be on mute.
Thank you. Thank you so much, Kelly. That was really helpful. I'm going to pass it back to Nick, who's going to help us have some questions from the audience for you, Kelly. Thank you so much.
Great. Thanks, Jack. All right, first question here is, can you provide more detail on what competition for a market would look like and how this would be managed?
Sure. So the idea is the short-term market operations, that's the market, that's the spot market, whether that's through an RTO with an LMP or whether that's through an imbalance market, those would be where the market is. And the competition piece outside of that would come for the competition to decide which resources are available to grid operators to enable those market constructs. So each of those designs that I walked through, those are ideas for how you would have competition outside of the day-to-day market. So you would have some entity running an auction, you would have all kinds of different buyers and sellers within that market, but those would be the resources that are then available to grid operators. But the idea is to ensure that you have both the kinds of clean resources and the kinds of resources that enable you to meet reliability requirements. Not that those two are necessarily separate, but some of the designs point out that it's much more difficult, or could be much more difficult, to rely on renewable resources on their own. They might need to be in specific combinations in order to do that. So if you have an auction that actually explicitly requests to have the combination of resources that enable you to meet a reliability requirement, you could do that.
Thank you. All right, the next question is there one or two of the proposals for long-term resource adequacy that are emerging as most appealing in the West?
That's a question I don't know. I have not heard any discussion on any of these market designs yet. So I think they're out there, they're being proposed, but as far as their application in the West, I haven't heard, I haven't really heard that yet.
Okay, that's good to know too. All right, what is the difference between managing transmission by contract path or by price?
Yeah, so in an RTO, transmission access is managed by price. RTOs use a location-based marginal price that has a congestion price in there. So when resources are dispatched, they are dispatched by price. And if there's congestion on the system, that is reflected in the energy price. So it becomes clear in those markets, or the idea is that it becomes clear where it's most beneficial to site resources because of congestion constraints. In markets that manage by transmission access by a contract path, they are managing, like I said, to ensure that you already have predetermined authorization, if you will, right, to have your electrons flow, your generation flow. You have firm transmission rights, for example, associated with your generation resource, and there's a predetermined authorization that you can flow on that line. Now, in both of those markets, grid operators are still managing the system, recognizing that electrons flow according to the path of least resistance, and they're managing according to these mandatory reliability requirements. So it's not that in that part, it's not different, but in how you manage transmission access, that's the key difference.
Thank you for that. All right, our next question is around the long-term markets. Are long-term markets used anywhere?
In the way that I've talked about these designs that are out there, none of those markets are in use today. But the recognition that the resource adequacy concepts that are in place today and the resource adequacy markets that are in place today, that those may need to change, that is not an uncommon, that recognition is more common, right? But as far as what we do about that and which market design and which auction structure we use and how we can start to potentially rethink market designs that are in place today. There's not really a consensus, there's nobody that's sort of figured it out yet. I would say everybody's grappling with this around the world.
Yeah, you might have started answering the next question and our final question here in that last comment, but I'll ask this final question anyway. Is WRI or other experts building out long-term market frameworks?
Well, so there are, yes. So the markets that I laid out on that slide, there are attempts to start to think through this and start to think through what we might need. WRI and RFF, Resources for the Future, hosted a workshop, I think about 2 years ago now, where we started to talk about what are these market design options, what are some of the challenges, what are some of the things we still need to be thinking about, including who runs those auctions, right? Who decides which resources need to be procured? Those are still questions that everybody's grappling with. So what WRI is trying to do is at least put research out there to say, here's what the different market designs are, here's what they may help with, and here are some things we need to be thinking about.
Great, thank you. All right, well, with that, we are concluding our Q&A section as well as the webinar. So thank you all for joining us, and keep an eye out for future SEBI webinars. Hopefully some of your suggestions are turned into webinars. And thank you again. Have a great rest of your day.
Thank you. Take care.
Thanks all.